The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, good morning, wherever you are in the country. It's Mark from SolidCAM. We'll be doing SolidCAM Live today, our 30-minute free training session for everyone in attendance. With me, as always, if it bleeds, he can kill it, Kevin Rankle. Now, if you know what movie that's from, please tell me in the questions. But that is one of my most favorite movies. Okay, so, sorry?
Spider-Man?
No. See, I'm a huge comic book guy, but no, my favorite movie is not comic book related.
Oh, okay.
A hint, it's one of the ones that would have been on TV all the time back in the day when I was growing up. For you guys, it might have been on, I guess, maybe a local station like TBS or something like that. For me, it was any of my usual American affiliates. But yes, the classic movie. If you tell me what it is, I'll be happy for my Friday. So today, we actually have some more questions. Say it again, Jake? No, you have to watch the recording.
Sound cut out.
Oh, sorry, okay. If it bleeds, he can kill it. But the original line is, if it bleeds, we can kill it. Anyway, so speaking of Jake, we got 2 emails from him with a list of questions. And I'm going to answer them in reverse order because I think the last one he sent right before class is really quick, and it's probably a question that most people have. And it's pretty much the purpose of the feature that exists inside SolidCAM is exactly what he's asking for. Basically, his question was, how do you print out the tool table with things like how far it's sticking outside the holder and the proper position that you'll be putting it on your tool changer or your turret, whatever machine you're setting up? And basically, that is, if you remember from, I think maybe a week ago or 2 ago, that was the tool sheet. In the tool sheet, you get the ability to output all the information or most of the information you've plugged into your file here. If I just click generate, it'll open up a Word document with my tool list, my operational summary, a lot of different information there. But to specifically answer Jake's question, tool table as in the dimensions, how far it's sticking outside the holder, and its position in your tool changer or your turret is listed in the, let me just say yes to this Word document. So just bring this over. So like we saw last time, it'll actually tell you what units the file is in, what type of file it is, what post was used, tool adapter, number of operations, where the original SolidWorks file was kept, where this file is kept. And if you scroll down past some of this, here is your tool table for this particular part. So outside the holder, that is that same dimension that you plugged in when you defined this tool, the OHL length. You can actually see what holder is being used here if I had one defined. This being a Word document, you can plug in as much information as you like. So if you had a location of this tool in your shop, let's say you got your tool shelf or your whatever you guys are keeping your tools, you can put the location there. You can put a barcode here if you have that sort of a system, and you can put notes as well. Whatever holder could be represented here, you can put that information there as well. But specifically outside the holder, dimensions of the tool, and then its actual position as well. So you can see here you've got your offsets there. So H1, D1, H23, and so forth.
And now the cool thing too is, go ahead, close out of this for a second, Mark, and because Jake's asking how do we get back to that. So go ahead and right click and do the documentation tool sheet. And then right here, if you guys are just looking for just the tool table only, Mark can come in here and uncheck everything except for the tool table. So that way it will just generate just the tool table by itself. So this makes it really easy for going out and setting up the job on the machine. You can just do the tools only.
So I hit generate, it's going to open up on my other screen, hopefully. There it is, okay.
And now,
so, just like Kevin said, you can see it's just the tool table now.
Yep. So if you're just looking for specific area, items, or maybe you just care about the first initial page, you can print off whatever pages you would like in there.
Absolutely. I mean, the template will read all this information, but of course, there's probably stuff in here like that main page you don't necessarily need, or you're not looking for an operation summary. This is probably a simple job. There's no need to really print out all the two operations that are there. But the tool table, definitely, that's exactly what I would do as well. Include that with whatever job folder you're sending out to the shop. Okay, so Jake's question was that right-click on tool? That is right-click on CAM part. So even though you have a tool table here, the actual tool sheet, the setup sheet, is generated right-clicking on CAM part, documentation tool sheet, and then tool sheet.
And kind of along that same lines, let's go ahead and show them exporting out the tool table. So for this specific job, to an Excel. So
okay,
go ahead and export all.
Okay, so
and now what Mark can do is switch it over to an Excel file. And what it will do is it will export that tool library out with all that information in there. Now it's going to have a lot more information in there. It's a little tougher to go through, but it is all there for you. So the diameters, radius, teeth number, all that. It's just not in a nice, pretty look like the setup sheet.
Yeah, I think the purpose of this is more for a massive data dump of your tool table. There's a lot of times where you're going to get an Excel file or a CSV file from your tooling supplier, and they'll have thousands of tools on here. You're not going to go and individually define each one. So this is an easy way to do a mass data dump of all the different tools. And you can see here that it's in Excel. So you can actually do Excel features here where you can actually get it to just incrementally increase. Let's say you want to do 1/4 of an inch, 1/2 inch, 3/8, 3/16. Like you want to just kind of do the range of tools there. You can actually do your math, or you can do kind of features, whatever, to get that to auto-populate. And then if you've got many of them, this is an easy way to just load all of them in one click. It might do some thinking in the background, but then eventually you'll have a tool table that has all of this in place. And this is actually the procedure we recommend to do that. Output it first, get these headings, and then if you did get a tool table from a supplier, modify that tool table so that it matches these headings here, and it should automatically populate back inside when you import from an Excel file.
Yep. So we also have another question that's somewhat related. So if we have a shape tool just locally, how do we get that into our global library?
If you have a shape, I guess if it's a shape tool or a shape holder, I think the answer is going to be basically the same. You want to define those globally anyway. I don't really know if there's, a shape holder, Jake's saying.
I think where he's getting at is if you open up your tool library right now, your local one, and let's say Mark grabs a holder here, and just grab any one and just now go to edit shape and edit. Now at this point, you guys can go in there and completely edit that holder. Now, we won't do that just so Mark doesn't mess up his tool library, but let's say Mark made a change to this holder now. So now what he can do is he can either export this tool with the holder out to the library, or he can open up the global library and import that in there as well. Is that what you're looking for, Jake? Okay. So, and that's as easy as, so he made the change to that tool number 1. So he's got a 1/4 inch with that holder in there. So now what Mark can do is export that tool. Yep. And then selected. And he can put it into the library this way. The easiest way I like doing it is if we shut everything down, go ahead and save that holder, or do a save and exit. Now you can cancel this.
Okay.
And now go ahead and open up your global library.
Should I close out of the file?
Yeah, yep, sorry.
No, usually the procedure is close out of the file, because if you're going to do anything globally, you want to make sure you close out. That way, you can save it and then incorporate it later when you reopen that file. So tools, SolidCAM, tool library.
And no, do edit tool library. Just grab any one of them, don't matter. And now what Mark can do is he can import a tool. No, go as to like you're going to import a tool from a CAM project is what I was thinking.
Oh, okay.
And so what this is going to do, this is going to bring in the tool and the holder. Now, Jake, you're just looking for the holder only. And in that specific case, we can't do just the holder because in the local library is not set up to create a custom shape holder off the fly. It's set up to modify the library, but it's not set up to completely build it. And at that point, what you'd want to do is import that holder in there. So what you could do is just take a screenshot of the dimensions of that holder that you made changes to, and then put those in there. But there's no way just to export out just the holder inside a local library. If that makes sense.
Yeah, no, that it does, and that's why I was saying that probably a better procedure would be, just like Kevin said, get those dimensions and then make it globally to start. So get the dimensions, close out of the file, and just do the global definition of that holder, and then it's always global, rather than trying to go from local to global sort of thing. And that's kind of a general thing for all kinds of tool table functionality. It's usually better to do it globally, and then it exists for all part files.
And yeah, and that's to answer. He's asking if we can build it in the global library, and yes, you can build it in the global library. And that's okay. Instead of going into open up your global tool library, you're going to open up your shaped holders, which is also considered your global holder library at that point. Yes. Does that make sense, Jake? And you don't have to yell at us. I see all the caps.
All caps. Okay, so I think we have a question from Scott.
Yep.
Also, tool sheet in SolidCAM operations toolbar. Oh yeah, you can get it from there as well. I guess a lot of times I do it the old school way. I just right-click and get to the right-click menu. But there are along the top. Let me just reopen the file.
Yeah.
There's a lot of new functionality in the ribbon.
That's what I have a hard time using that ribbon just because I've been using SolidCAM since 2007 and we never had that ribbon up there. So it's always right-click, add operation. But to go off your point, Scott, yes, you can just click on the ribbon, and obviously Mark and myself, we always forget about that one as well.
Pretty much every functionality exists in the ribbon now. So you have your tool, you got your new part here, open, close, calculate all, generate, tool sheet. In the ribbon, you can also see there's views here. And if you remember from a couple of days ago, I was talking about the coordinate system inside SolidCAM versus the coordinate system inside SolidWorks. These are views generated only by the SolidCAM coordinate system. So the top view in SolidCAM is going to be along this Z, whereas the top view in SolidWorks might even be a different Z completely. So let's say that's front view, that's top. Actually, I think because we're still working under that one. Yeah, it looks like it. But you can see because the Z is different here than here, then the views would be different if you're trying to call a SolidWorks view. Okay, so let's go through the list of questions. I think most of it is the same, although Brian has a question. So what is documentation DPP and how is it supposed to work? That is a question for Kevin because I don't know.
Sorry, I didn't.
This guy right here, what does this do?
To be honest with you, Brian, I've never used it.
That could be one of those old, there's a lot of old legacy functionality still inside SolidCAM from times previous to probably, for sure myself. So if Kevin doesn't know what it is, then it's probably really old.
I'll tell you what, Brian, what we'll do is we'll research it and then we will get with, we'll cover this Monday. If that works for you.
Yeah, sounds good.
I don't want to tell you something and have it be wrong, so I'm definitely fine telling you that I don't know.
Yeah, let's write that down. Okay, further down the list, okay, in regards to custom tools, you have a lot of tool shapes, but not corner rounding. Is that something you can add? I'm not sure what the new tool table that we keep talking about is going to have, but correct, there are certain shapes of tools that don't currently exist in the default shape window.
Which,
So,
in your guys' defense, we have been asking this from development for a long time. I don't know why it hasn't been implemented in there. If we can implement a, the barrel shaped tools and the oval, all these weird ones, why can't we just do a radius
that's what I was
one?
about to say. Yeah, I was definitely going to say that too, because it's a lot of people have never even heard of these, but corner round tool is like, it's,
Yep.
yeah.
So, and like what Mark said, there is a new tool table coming out for 2021. It is going to be a completely different tool table, and I think that's kind of where, when they first initially built this tool table with the source code, is if it wasn't added in there right away, the ability to add it in at a later date wasn't there. So I think that's kind of where it's at this point. But with the new 2021 tool table, we should be good for another 20 years and be able to support all the tools. And then in 2060, we'll have to go through and redo the tool table again.
No, you heard it here first. 20 years.
Yeah. And let's see, who is Scott? Scott, do you understand how to create those corner rounds on the fly right now with the shape tool? Yes, but not efficient.
No, but not efficient. Okay, it is a weird shape to work with, the torus or whatever it's called. But once you get the hang of it, well, keep in mind, once you define it, it's part of your global library, so you don't have to ever do it again. But also, you can make a copy of it and just keep changing one dimension on it to get all your different shapes and sizes of corner round tools. So that's another nice little functionality. Just make a copy and then just change whatever you need to change.
And I'm just doing a quick search here. I did make a corner round tool back in 2016. That's step by step. Let me just put that in there.
The CAD/CAM video you're talking about? Yeah. So you'll find a lot of stuff on the YouTube channel regarding shape tools. Like Kevin said, he's going to put a link in there for the corner round tool. I think I made one for how to use a double-sided chamfering tool.
Yep.
Shape tools in generals, shape tool holders, that sort of thing. A lot of the YouTube channel stuff is basically questions that we've gotten over the years, and we just made a video on it because it's sometimes easier for you guys to look it up as a source, the YouTube channel, and then you can find something real quick if you can't get a hold of us on the phone, which doesn't matter. I mean, you call us, we're always available, but sometimes there's a quick question where you just want to kind of get an answer without having to call somebody.
And Scott, if you watch that video, and I put it for Scott, but I put it for everyone now too. If you still have questions about that, shoot me an email, and then we can walk you through step by step through it. I don't want to do it here just because we did that. I think 2 weeks ago we did the exact same holder in there. So, but if you do have questions, just let me know.
Yep. So I was trying to work on a segue, but segue into Jake's other questions, which are kind of a good set of questions for a Friday. I think it's a good kind of roundup for the week, roundup for what we've been talking about. I'm actually going to put those on screen so we can all take a look at them. So basically, what is your favorite, let's say, top 3 function, feature, and operation inside SolidCAM? So I was thinking I would go through the list, give you my answers, and then we can go through the list with Kevin. We can get Kevin's answers. So my answer for the top 3 that are my favorite, as much as you can have a favorite, is the SolidWorks integration or the associativity, because I find that that's really useful for a lot of the stuff we do inside SolidCAM. You want to just program your part once, and then any kind of changes that get made, you want the software to automatically do it for you. So the associativity really helps out. In that same vein is things like stock recognition, hole wizard, adding the fixture assembly. Those are SolidWorks functionalities that we can use inside SolidCAM. So it's a SolidCAM functionality to use those things, but it's all coming from the fact that we're integrated inside SolidWorks. So that's 1. 2 is HSS morph between boundary curves. have to
You
choose the
can't
two
take
curves.
mine.
I told you get your chance, man. Okay, so Kevin and I both agree on that one. HSS in general, I think, is a good toolpath because when you're doing finishing, it's a lot of the times it's about the look of it, right? I mean, that's why we're finishing it. So HSS, morph between boundary curves, gives you the ability to really kind of smooth things out as you go across a particular surface. Sometimes you got to, modify the parameters a little bit to make it look a little better. But in general, starting with that, you'll get a good finish on your surface. And then lastly is 3D iMachining. It is our flagship toolpath. It encompasses everything that we like, or at least I say I like about SolidCAM, the integration, so stock recognition. It calculates feeds and speeds based off of some hardcore data like ultimate tensile strength and the limitations of your machine. And it does a lot of the work for you, because if you don't use that, you're looking at trying to do some sketching to limit the travel of the tool. You're trying to tell it exactly how you like to go around. Whereas if you just do 3D iMachining, you can say, okay, here's my part, here's my tool, figure out the nooks and crannies, and then I'll give you another set of tools if you need it to go a little deeper into the part. But a lot of times it's basically, like a set it and forget it sort of situation. You just say, here's the tool, here's the part, do it. Number two.
Well, okay, let me take on the top three now, only because
Okay.
I want to do a little explanation of why on mine as well. So, Mark, can I get control of your computer?
Sure.
He says that.
I got to figure out which one of you didn't change your name in the list, so now I got to figure out which one you are. All right, let's go. Give keyboard and mouse control to Dr. Kevin.
Which is false advertising. Okay, so like Mark was saying, HSS, morph between boundary curves, is probably one of my favorite ones. And the reason why is, let's just open up this one right here. I think this one is morph between, no. Actually, what I'll do is I'll just start a new one here.
Sure. And while Kevin's starting that up, still nobody figured out what movie that was from, my line there. If it bleeds, he can kill it is from Predator.
What year was that movie out?
Oh man, 1987, I think it was. That was on all the time. Back in the days of VHS, that was the first time I ever recorded a movie that was on at 2 a.m. And then I would watch that over and over again.
All right.
But that's not my favorite line from the movie. My favorite line is Arnold pulls out a knife, throws it at the guy gets pinned against the wall, and Arnold says, "Stick around." Nobody's laughing. All right.
They're just laughing at you. Okay, so here, like Mark said, morph between boundary curves is definitely one of my favorite ones in here. And the reason why is, if we start off with a circle up here and we're starting off with a circle down here, it's really not doing any change. But when we have an oddball surface, so if we're going from a circle to kind of an oddball surface, like maybe a square, what it's automatically doing is morphing and working its way to transform the toolpath into the bottom shape. Now, the main reason why I like using this one is under the Toolpath Parameters. A lot of people miss this, is under the sorting, I like switching this over to spiral. And that way we are keeping that ball end mill or a bull nose end mill in contact with the material constantly throughout that entire cut. So I'm not getting any witness marks. I'm not getting little divots in there or anything like that. Is definitely why I always come here, and like, especially with, radiuses like this, to go out and buy a radius cutter like we were just talking about for that shape tool, to have one for every radius does get a little expensive, but if you're running high production, then you can definitely buy it. But by doing it this way, I get a nice smooth cut. And like Mark's saying, you get that beautiful finish. Now, for my second one would be, same as Mark again, but would be the 3D iMachining. And Mark kind of explained all that for you. But my thing I like using, let's see, see. No. With 3D iMachining is even on a 2D part, I will use 3D iMachining a lot. I'll set up some stock so I can show you here.
Well, there's stock. We just need to add the iMachining definition.
Yeah.
So just do a pull down. We got it in there.
Okay. So even on a 2D part, I will use 3D iMachining. Now what I'll do is I'll come in here and switch it over to Prismatic. And what I'll do is I will come to my technology, and depending on the material I'm cutting, I'll leave, maybe 5 thou on the wall and 5 thou on the floor. Now, with 3D iMachining, we actually did this at Toyota. They were making wax molds, and we were able to, it was a fully 3D part, so it wasn't a prismatic part. So what we were able to do is leave it on general, and what we did is we switched our scallop to be a very small scallop inside there to get a decent finish. And we were actually able to get a fully finished that met their finish requirements using just 3D iMachining by itself. So that's why, it's nice. If you're not looking for the greatest finish out there, you can set the scallop at, 5 thou, and you'll actually get a, when we're doing these molds, the finish was phenomenal. I was really blown away on how smooth it was in there. So there is that option there. Now, kind of going back off pace, back to Prismatic, what I like to do is if I have a part with just a ton of pockets, I will use 3D Prismatic and then go to my last favorite toolpath, which is,
I was going to say before you leave that, if anyone noticed, when he was toggling between Prismatic and General, you saw that really the only difference was that scallop that he was talking about.
Yep.
Because Prismatic just eliminates the ability to add that scallop. But
Yep.
that interface is the same between the two.
And to lead off of that Prismatic, what I'll do to get that really nice finish in there is I will come in and do my 3D HSM, and I will switch it over to horizontal. And what horizontal will do is it's really good at cleaning up the flat floors and the flat walls. So long as I don't have to have multiple step downs, in which I shouldn't most of the time, is I can come in here and I don't have to chain anything. I don't have to do anything. I can just grab my tool. I can come to my passes. Grab a tool real quick so I can get to my passes. And I can set up my offset of how much do I want to step over at that point. Now, inside of HSM, you do have the option to do prismatic machining as well. So with prismatic is going to be pretty much the exact same thing as horizontal, but it's going to be more set up to do step down. So if we have a really tall wall and we can't take it all in one cut, now we can set it to prismatic. So to do this part that has tons and tons of pockets, to go in 2D iMachining and manually pick all those is going to take a little bit of time, where I can do it in 3D iMachining, get all that material out of there, come over to my prismatic machining or my HSM horizontal, and like I said, if we're looking for a step down on the wall, I can set that there, and I can set my step over, getting that really nice pretty finish. And what I mean by the pretty finish is you get those nice contour lines going in there. Because as iMachining, you can set your finishing with iMachining, but you get a lot of the swirl marks. It's just a visual. It still feels fine and everything, but you will see those swirl marks inside there. So those are my 3 favorite ones that I use on a consistent basis. So like I said, even though it's set up for 3D parts, we're talking 3D iMachining and HSM, where it's more geared towards 3D surfacing. These 2 tool paths work phenomenal for doing flat floors, flat walls, as in prismatic machining. So And I think since I rambled on so long, we're gonna have to hold off on the other favorites for Mondays. Leave you guys on a cliffhanger.
Well, I mean,
you guys, I want to give you guys a good detailed explanation of why this is our favorite toolpath versus just saying, I like this one, I like this one, I like this one. So maybe you guys.
No, that's a good. That's a good point. We can do like our favorites and then examples of the why they're our favorites. So I'll make that a note of that as well. We can do that kind of a cool kind of favorites. But I want to finish up this list because I think we can do this real quick in the next couple minutes here. What is the most underutilized function / feature / operation inside SolidCAM? From my perspective, it's things like the transform command and iMachining in general. The reason I say the transform is because a lot of people, when they see the repetition of their parts, repetition of features, they don't automatically think to use something like a transform, or either a rotation or a translate. And then iMachining, as a training manager, there's a lot of times where I have to explain what iMachining is because sometimes they don't, a lot of people don't, they see what it is, they know it's complex, and I used to call it black magic. They don't understand how it works, so they don't want to touch it because they don't want to screw up their machine. But that's my perspective. What do you think, Kevin? What's the most underutilized that you've seen?
I would say the most underutilized one that I see is the transform, as well as the I number of fixtures, or multiple work offsets. You guys are programming, one part, but you got 5 vices and you want to run all 5 of those parts at the same time with different work offsets. That would be a big one of, was on a call with a customer yesterday and he had 4 of the exact same parts and he's trying to program all 4 parts, and there's no need to even do that. Let the software take advantage of that, as well as renaming your Macs. So as we know currently with Mac 1, it is going to be G54, Mac 2 is going to be G55, Mac 3 is going to be G56. But you don't need to do that. So if Mark is just programming Mac 1, he can just type in 56 and it will automatically post out G56 for you guys.
I'm using an older post. So in the newer posts, you don't have to do this, but in the older posts, you have to turn this guy on.
And everybody that is in the webinar, for a new post, all you guys are running 2018 or newer, you guys do have a new post. So you can see G56 is automatically produced right there. So that is a big one, switching that over. I mean, there's a lot of, I see a lot of stuff that that people are struggling with, where it's like, well, if you just think of it this way, you could do it this much faster and better. It's just, we could be on here for hours on stuff that's underutilized.
There's a lot of functionality inside SolidCAM, yeah. So it would be fair to say that almost everything is underutilized, but it is the fact that, all of us that have worked in a shop or you're currently in a shop, there's no time to play with the software and take your time to figure out the details. That's for me and Kevin to help you with. That's our job, to tell you where the details are. You guys, you just need to get code on the floor. You got to get producing parts. We'll help you when you have a question. But definitely a lot of stuff can be underutilized if you don't know about it, right? So it's like Kevin said, those items, the renaming, the transform, and I guess I get a lot of new guys, so a lot of the iMachining gets underutilized because they're new to the software, new to SolidCAM, and they don't want to mess with it if they don't really know how it works. But those are good answers, I think. So the third question there, what are some of the things people always get hung up on, and how do we avoid them? So that's kind of a good follow-up to that underutilized. What I would say people get hung up on is things like HSS versus HSM. I find a lot of people, they look at how our stock recognition, our part recognition toolpaths do the entire part, and they just want to get that done. They want to just, again, kind of a set it and forget it sort of scenario. But a lot of times HSM there is the boundary condition, the boundary areas that you can set up to really dial in the tool. Or they use HSS in a similar manner, and they're there forever clicking on every surface. So I find that a lot of people get hung up on trying to do the entire part with one toolpath, where it's easy to do a save and copy, change your technology in HSM, or with HSS, save it for detailed areas. You don't have to do the entire part. You can do different strategies for different collections of surfaces. At least that's what I have found. What do you think, Kevin? What do you think about getting people get hung up on stuff?
Yeah, this is one where I'm going to have to leave you guys on a cliffhanger, because the one that I want to show you, and I think that's going to really help you guys out, is going to take me about 15 minutes to explain and show. So
okay, perfect. So that's we're going to have Kevin's we're going to have KevCam live during the day next week. Okay, so while we're trying to finish this up, so number 4, what are some things that CAD designers often overlook when designing for manufacturing, and how can we work with these people to help them design parts that are easier to machine? This is a classic question, because I find in our industry it's usually engineers/designers versus machinists. And I've been on both sides of that coin. So I kind of know where this question is coming from and the answer that I would give. And that is corner radiuses and tool possibilities. I've done some designs where when I was new, I didn't realize that that corner rad is impossible. A tool doesn't exist with that radius, or you're basically trying to account for the design of your part, but there really is no way that a tool is going to reach there, or the angle that the tool is going to take on your 5-axis machine is not possible on your machine. The machinist either can't see it, or there's not enough reach for the tool. So that's what I would say. If you are trying to help out your designer/engineers friends over there in your company, show them what a tool looks like. Help them understand that a tool is cylindrical, or it has a cone shape that they can use to better design things like corners and stuff like that. It's impossible to do a sharp corner on the bottom of a tapered pocket without getting some sort of corner radius. Or if you're going to do like a really long drilled hole, make sure it's not a little spaghetti kind of drill that's going to wiggle. At least that's my perspective. What do you think?
Yeah, that's exactly what I would say too, is, being programmer, the designer does, FEA analysis on the part. They got it all exactly for the stress analysis of that part with a 10th thou radius that is an inch long in a corner. Well, that means you would have to have a 20 thou end mill to get in there, and a 20 thou end mill that is inch long of cutting length that just does not jive. So definitely that's the biggest one that we run into, or that I've run into there.
And for the last question, are there secondary operations that can be done inside SolidCAM, like the broaching we did the other day, that machinists might be doing off the machine that would be better done while the part is still in the machine? So basically manual versus CNC. My perspective, a lot of the times people will do turning operations faster than they can program them. So I would think that maybe I'm thinking the other side of that question. It's better to do some turning manually than programming, because it's just going to take forever to program it versus if someone just kind of does it manually. But this is the sort of question that can be answered with experience. So I'm going to defer to Dr. KevCam over here. So what do you think on that one, Kevin?
I would say probably the one big one that I see a lot is engraving part numbers. With part numbers, it is so simple and easy to add a quick part number to the part and do a quick engraving on it than it is to bring it over to secondary work and either hand punch, because I used to do it, hand punch the part number onto it with a hammer and punch, or having to buy a secondary engraving machine and doing it that way. Now, the funny thing is, with those secondary engraving machines, to do a part number, we did a time analysis on it, and it is quicker to do it inside of the machine than it is for that secondary work, or that secondary engraving machine to do it. Plus, you have to have a second person to run that machine, where when you do the engraving inside, it's already done there for you. So,
and I just thought of this too, deburring, right? If we did like a chamfer recognition or something like that.
Yes, deburring as well. Now, granted, if you have a very long cycle time, and I'm using my experience from a shop that we had close to 60 CNC machines. Some cycle times were 30 seconds. Some cycle times were an hour. So if we had an hour-long cycle time where we seen an operator sitting on his butt and playing on his phone, then we would eliminate those deburring operations in the machine. So the user or the operator down on the floor can be deburring while it's being done. Now this comes into, if you are the reverse role, a very short cycle time where your operator is constantly having to take parts in and out, and not having enough time to do that, deburring is very helpful inside the machine. And one that I see that I don't see very often is they're called cogstail drills, and what it's set up to do is set up for deburring holes. So it's a spring-loaded carbide little bit where it will come down in the hole, sit there with a dwell for a second to deburr off, and then it will push straight through. And by spring-loaded, it will pop back out once it hits the bottom of the hole and deburr, the top side and the bottom side of that hole within a matter of seconds, where if you have to pull that part out and do secondary work on it and the operator still doesn't have enough time in the machine just to barely unload and load parts, that's good to do it that way too. Long-winded answer of it.
No, I mean, it's exactly what I'm guessing Jake was looking for, that kind of idea there. So that gives them some ideas on how to streamline the production life of some parts there. Looks like there's one last question for today. Can we do an engraving webinar in the future? Yes. So yes, Robert, we can focus on engraving in the future. There's actually some good functionality just in that one toolpath as well. So we can cover that, I guess, next week. We can do that next week.
Yeah, we'll do the underutilized function. Finish up my answer for that one on right away on Monday, and then we'll hop into engraving for you, because it is awesome. Very simple and easy to do.
Yep. Okay, so we'll leave it there. Like Kevin said, we'll do some of those, the favorites, underutilized, and engraving next week, so that preloads our list for next week. If you have any other questions, any other topics you want covered, Kevin's going to put my email in the chat section, so you guys can send me more questions, topics. I got a request to see if I can do a special intro. I'm going to try and remember good intros from that movie, Jake, and we'll put it into the next one.
We need a cliffhanger. Wasn't it a cliffhanger? Oh, intro. Okay.
Cliffhanger's a movie. Cliffhanger so that's just alone.
No, I think he's made a good cliffhanger for Monday, and as an outro. Is that would that be like, this is how the cookie crumbles?
Yeah, Jake is meaning the movie, man. It's been movie week. Okay, I'll come up with something, Jake. Topics, questions, anything you got, there's my email. Cat's out of the bag. Yeah, okay, everyone wait for the cliffhanger for next week. Email, questions. If you want some personalized training, you can use that email as well. I'll help you schedule your training either with myself, Kevin, all the guys on the team. SolidCAM, help us sell it. If you've got a friend that could use some SolidCAM, get them in contact with us. There's a finder's fee associated with that, even if it's just a demo. Something comes your way, even if it's just a demo. And we'll continue this next week, 2 p.m. Eastern time. You can use the same link to get into this one, and we will talk to you guys next week. Have a good weekend. Keep your family safe, keep yourself safe, and I guess it's Mother's Day this weekend too, so let's all remember the ladies in our lives.
All right, guys. Have a great one.
Okay, bye.